All right, so the first topic that I want to discuss here is magnetic field created by a moving charge. Okay, so magnetic field created by a moving charge. Okay, so let's think about it. How is a magnetic field created? Okay, the only way magnetic field is created is by having an electric charge moving in space. So as soon as you have an electric charge and as soon as the charge starts to move, magnetic field is created in the space. Okay, so we have a charge, and if we get this one moving, we create a charge. Now you can think of magnets. They don't have any moving charge. They look steady, but in fact, they do have a moving charge in the sense that there are electrons in the atoms and they are moving and spinning. And the motion of those electrons creates a magnetic. Okay, so how is that magnetic field create? How does that magnetic field calculated? What we can do is we can use an equation for that, which describes the magnetic field B from a moving charge in terms of mu naught over 4 pi times Q, which is the charge of the electric field, V, the velocity of the magnetic field, divided by R square cross R hat. Okay, so what it is, basically, if you have a moving charge like this one that I draw here, and let's imagine you want to calculate the magnetic field right here at position R. Okay, so this is the velocity, how fast it's moving in the direction of motion. And here is the vector that connects the charge, position of the charge to the field point. And the R hat is a vector in the same direction of R, but with the magnitude, the length being only 1 unit. Okay, so the magnetic field created here at this point is mu naught over 4 pi QV cross R. So this is a cross product. That means the magnetic field is going to be at the end perpendicular to the direction of motion and to the unit vector that we have here. That means that for a sort of configuration that I have right now on the screen, the magnetic field is going to be, in fact, perpendicular to the surface of the screen. Okay, so it's going to point either inside or outside the plane of the screen. Okay, so with this one, we did a calculation. We did one example, and that example was a case that we had 2 protons. By the way, that's example 28.8. We did that in class, so I'm just gonna quickly go over that. The example was we have 2 protons, both of them having positive charges, of course, both of them moving with the same speed but opposite direction. Okay, so let's call that V and minus V, and then we calculated the magnetic field, magnetic force from each of them. Okay, and it turned out that magnetic force is going to be repulsive between them, and that has to do with the direction of magnetic field created and the direction of motion. If these charges were not moving in opposite direction, had one of them moved this way, same direction as the other one, we would have end up having the magnetic force that being attractive between the two. Okay, so to create a magnetic field, we need an electric charge. We need to have that electric charge moving, and that motion creates magnetic field in a space. And the direction of motion defines the direction of the magnetic field as well. Okay, so there are some, as you see, there are some fundamental differences between magnetic field and electric field. Electric field is always diagonal, is always in the same direction of direction of a connecting vector from the charge to the field point, but magnetic field is pretty interesting. It's created by a moving charge, but the direction of the magnetic field is perpendicular to the direction of motion of the charge and to the direction of a vector connecting the charge to the field point. Okay, so we talked about the force of magnetic field in the previous section. So if you do have magnetic field in a space, that can exert force on moving charges. So in the example 28.1, basically we use both knowledge, first knowledge on how a magnetic field is created and how the magnetic field exerts force on a moving charge. Okay, so I'm gonna move on relatively quickly, okay, because this is something we covered previously, and now I want to look at magnetic field of current. Okay, so if you have a wire, okay, let's imagine, let me write the topic first. You know what? I'm gonna stop the recording and continue in a separate video so that the browsing and watching videos becomes easier for you guys. So let me go back here, stop it. Okay, I'm gonna stop it and I'm gonna start another video right away.